Welcome, welcome to our session. So this is type 2 in the homogeneous equations. So here we can take as f of d comma d dash and z is equal to 0. In RHS we can given the exponential term. So e power ax plus by is given. The coefficient of x is our a and coefficient of y is our b. So the given problem is solve dou square z by dou x square minus 5 into dou square z by dou x dou y plus 6 into dou square z by dou y square is equal to e power x plus y. So the given partial differential equation is d square minus 5d d dash plus 6 d dash square into z is equal to e power x plus y. So since the given equation has a homogeneous linear partial differential equations, so replace m is equal to 1 and m dash d dash is equal to 1. So we can get auxiliary equations. So since quadratic equation, therefore we can factorize it. We can get m minus 2, m minus 3. Therefore roots are 2 and 3. So replace our m1 is 2 and m2 is 3. We get the complementary function. So the particular integral is equal to 1 divided by f of d comma d dash into e power x plus by. Here f of d comma d dash is d square minus 5 d d dash plus 6 d dash square into e power x plus y. Since the coefficient of x is 1, therefore a is equal to 1. Since coefficient of y is equal to y is 1, therefore b is equal to 1. Therefore we can replace d is equal to a and d dash is equal to b. Here a is nothing but 1, therefore we can replace d is equal to 1 and d dash is equal to 1. So the particular integral is we can get instead of d square we can replace 1. 1 square is this 1. Therefore instead of d is 1, d dash is 1. So replace it we can get so 5. Again instead of d square we can replace 1 square. 1 square is 1. 6 into 1 is 6. Therefore just we have to sum of these 1 minus 5 plus 6. So we can get 2. So since the denominator is non-zero, the process is over. You can stop the process. Therefore, particular integral is 1 by 2 into e power x plus y. So, the general solution is z is equal to complementary function plus particular integral. So, replace the complementary function and particular integral. So, we can get a solution. Next example number 2. So, solve d square minus 4d d dash plus 4d dash square into z is equal to e power 2x plus 3y. So the given partial differential equation is d square minus 4d d dash plus 4d dash square and z is equal to e power 2x plus y. So this is a homogeneous linear partial differential equations. So put d is equal to m and d dash is equal to 1 and RH is 0. So the auxiliary equation is m square minus 4m plus 4 equal to 0. Therefore roots are 2 and 2 repeated roots. So the repeated root means the complementary function is phi 1 of y plus m1x plus x into phi 2 of y plus m2x. So therefore complementary function is replace your instead of m1 we can replace 2 and m2 we can replace 2. Since it is repeated roots we can multiply x here. So next we go to find the particular integral. The particular integral is on the 1 by f of d comma d dash into e power x 2x plus y. So this is our f of d comma d dash. So here coefficient of x is 2 and coefficient of y is 1. Therefore we can take it as a is equal to 2 and b is equal to 1. So therefore replace it we can get particular integral is equal to instead of d we go to replace 2. So therefore 2 square is 4. So instead of d we can replace 2. Instead of d dash we can replace 1. 2 into 1 is 2. So 2 fours are this is 8. Again instead of d square we can replace 1. So 1 square is 1. So 1 into 4 is 4. Therefore 4 minus 8 plus 4 is 0. Therefore particular integral the denominator is 0. Since the denominator is 0 means further process is there. So therefore multiple x in the numerator and differentiate in the denominator with respect to capital D. So we can get this. Again we can replace d is equal to 2 and d dash is equal to 1. Again this also tends to 0. Since 4 minus 4 is 0, we can do the same process. So multiple x in the numerator, already x is there. X into x is x square. So 1 divided by differentiating this with respect to d, we can get 2 minus 0. So 2 minus 0 is 2. Since the denominator there is no d or d dash terms, therefore we can stop the process. So therefore the particular integral is 1 divided by x square divided by 2 into e power 2x plus y. So replace your complementary function and particular integral, so we can get a solution. Then example, so d plus d dash the whole square into z is equal to e power x minus y. So taken as the given homogeneous partial differential equation taken as the equation number 1. So replace d is equal to m and d dash is equal to 1. And we get the auxiliary equation is m plus 1 the whole square equal to 0. Therefore roots are m is equal to minus 1 comma minus 1, roots are repeated. So we can replace the m1 is minus 1 and x into m1 is minus 1, we can get a solution. The particular integral is 1 divided by d plus d dash the whole square into e power x minus y. So put d is equal to 1 and d dash is equal to minus 1. So the particular integral is the denominator is 0. Since the denominator is 0 means we can do the same process. So multiple x in the numerator and partially differentiating the denominator with respect to d. So we can get this, replace d is equal to 1 and d dash is equal to minus 1. So we can again the denominator is 0. So we can do the same process, multiple another x in the numerator. So x and x is x square. So differentiating this with respect to d, we can get 1 by 2 into e power x plus x minus y. So since the denominator is non-zero, we can stop the process. Therefore, this is a particular integral. Therefore, replace your complementary function, particular integral, we can get a solution. Thank you.